So there are basically 3 generations of solar cell. First one is the wafer based, which includes monocrystalline or polycrystalline. Crystallinity means how pure something is, like long range order of atoms, which is expensive because of the processing, which are very good, highly efficient.
How much efficiency we are talking about here?
25%, but they are very expensive. That's why they are not commercially available. Then the second generation solar cell, people talk about, okay, yeah, we can make 25%, but what's the use? It's so expensive. So we refined further. We have these thin film solar cell, which includes something like amorphous thin film, cadmium telluride, and copper, indium, gallium, selenium. With making things thin, give them conformality.
Next, come to the third generation.
That includes starting with the organic solar cell. We have moved away from the traditional material, silicon, to organic.
Carbon based.
Yeah, if we think about carbon, what's carbon? It's an organic thing. How can that even be conducting?
Right.
There is a Nobel Prize for this also to Professor Alan Heeger and co. There are several other. It's possible to conduct electricity even in organic materials. And in fact, the lab where I am in, it's called organic nanoelectronics. So basically, we are dealing with this kind of electronics.
It's like a polymer, right?
Yes, it's a
like
polymer. What if I told you that you already use this technology?
Touchscreen?
You're close. OLED TVs.
Even that quantum dots, those things, right?
Yeah.
Right.
That's also the third generation one. Coming back to that point, I don't want to oversell it because there are certain limitations. But the good thing is they are conducting. Now we can make liquid solution, like we can dissolve in some material and we can make ink kind of stuff.
Wow.
Now you see the difference in terms of cost. Earlier you required this big giant factory, billion expenditure. Now what you require? Chemists, magicians have made those molecules. You can dissolve in a solution any regular day in the lab. The ink has the capacity to make that photoactive material. Unlike the silicon wafer, now we have inks which can be made into thin films. These films are very thin. Like for organic, it's just 80 to 100 nanometer.
Wow.
And they have high absorption coefficient. Even with that smaller thickness, they can absorb the required amount of light that can be converted into electricity.